Tesla's first structural pack with the new 4680 battery cells will be ready to be in production. This is incredible. It's the whole floor of the vehicle, and then you can see the parts that connect to the front and rear underbody like they talked about on Battery Day. It's so simple. It just looks like a structural element of the car, but it's the whole battery pack. The new form factor eliminates the tabs, increases energy density, maintains similar thermal characteristics of smaller cells, improves the power-to-weight ratio, streamlines manufacturing, and lowers cost. The new revolutionary battery is going to be used in future Tesla electric vehicles, and it will affect the long-term production, especially Semi, Cybertruck, and Roadster. In this video, we're going to walk through each of the improvements that the new form factor brings to the table. How are they different, and what can we expect from the next generation of Tesla batteries? At Tesla's founding back in 2003, no one imagined the massive growth that lay ahead for the company. Or did they? Martin Eberhard's initial stimulus for starting Tesla was to build the EV he wanted to buy. But Elon Musk had a grander vision. He wanted to be the next General Motors. Tesla, which delivered 500,000 cars in 2020, would have a long climb to rival that giant. However, if the company's phenomenal growth rate continues, Tesla could be selling nearly 10 million cars per year by 2030, and it could become one of the world's top auto brands within a decade. Tesla aims to grow consistently at the rate of 40 to 50% per year. And to do that, it's going to need more and more batteries. Tesla's battery forecast showed a gap between the production limits of its battery cell suppliers and Tesla's internal demand for its automotive and energy storage business. 5 companies, AESC, LG Chem, Panasonic, Samsung, and SK Innovation, produced almost all of the battery cells used in plug-in vehicles in the U.S. market over the past decade, with capacity totaling 76,000 megawatt hours. Panasonic supplied 74% of all those cells, with a majority of those installed in Tesla battery packs for Tesla vehicles. Tesla intends to increase, not reduce, battery cell purchases from Panasonic, LG, and other partners too. However, with the cell suppliers going at maximum speed, Elon Musk can still foresee a significant shortage in 2022 and beyond unless Tesla takes action themselves. Tesla's relentless pursuit of vertical integration comes from a desire to eliminate inefficiency and improve sustainability of the product. A byproduct of Tesla's vertical integration is a much-needed improvement in cost, driving the cost of Tesla's products down over time. When the time came to design the new battery, Tesla looked all the way up the chain to the starting point. Doing this is a reflection of Musk's obsession with first principle thinking. He tries to start every design, every discussion with what is truly the lowest common denominator, the simplest truth, anchoring the product to the minerals they're comprised of. And when those are defined and refined over and over again, it's then possible to build an optimized design. One of the results of these efforts is a new 4680 tabless cylindrical battery cell format that brings a host of performance, manufacturing, and cost benefits to the table. As the name implies, the new jumbo cells are 46 millimeters in diameter and 80 millimeters in height. The larger jelly roll packs more active battery material into the casing for a 5-time improvement in energy storage and a 6-time increase in power. Scaling up to the pack, the new form factor alone delivers a 16% increase in range. The new cells are not the result of a single change to the size of the cells. The 4680 cells represent a fundamental rewrite of the history of battery cells at Tesla. Tesla simply built a new chemistry that's far simpler than the current process and allows for a higher percentage of silicon to be used in the cells. Silicon's the most abundant element in the Earth's crust after oxygen, making it a lower cost, easier to acquire commodity. In fact, sand is just silicon dioxide. The result? A cheaper cell that also boasts higher capacity. Elon Musk can increase the range of a Tesla vehicle another 20%. The icing on the cake is that the cells are also cheaper. That's another 5% cost reduction at the battery pack level. With Tesla being Tesla, a new blank sheet of paper was used to draft a plan to optimize each step to minimize waste and cost from core to cathode. Tesla's new high-nickel cathodes completely eliminate the need for cobalt. Chemically speaking, cobalt is a fantastic anchor for a cathode, but it comes with some serious caveats. Right off the bat, cobalt is toxic and produces a lot of waste. It's also extremely challenging to secure a source of cobalt that's sustainable, as the vast majority of cobalt production in the world comes from a single country, the Democratic Republic of the Congo. The country's leadership has not been in the most stable condition, and injecting hundreds of millions of dollars into an already corrupt system doesn't help matters. Ditching cobalt in favor of high-nickel cathode also improves the cost of a cathode by 15% on a cost per kilowatt-hour basis. And that's massive. Designing and manufacturing cathodes from the ground up also gives Tesla a great head start at building its own internal battery recycling systems. While the battery is a complex concept, it's best left to the experts if it's possible to have a general idea what Tesla's done here. The common cylindrical lithium-ion battery uses cells made of several layers or strips of chemical compounds to store energy. The layers are the cathode and anodes with a separator layer in between them. The cathode layer and the anode layer then connect to the positive and negative terminals of the battery using small metallic components known as tabs. The problem with tabs is they could be the downfall of the whole battery. Despite performing a crucial function, they can affect the battery performance and reliability if not done right. For instance, when the tabs are welded onto the electrodes, they could result in welding burrs that can pierce the layer between the cathode and anode layers, causing an internal short circuit. This has potential of causing a fire. Also, the step of inserting the separating layer between the cathode and anode layers introduces a time-consuming procedure during the battery manufacturing process. Tesla's new 4680 cell eliminates the internal tab, instead integrating the function of the tab into the jelly roll itself, resulting in a clean, uniform look to the end of the cell. Eliminating tabs reduces the internal resistance within the cell caused by an extra component. Internal resistance translates to more heat generation, a more complex manufacturing process, and higher cost. Tesla basically took the existing foils, laser powdered them, and enabled dozens of connections into the active material through this shingled spiral. Using this method, there's less distance for the electron to travel before reaching the positive and negative terminals. This is a win for physics and means faster charging times and more efficient discharge for the car owner, as explained by Elon Musk, the Tesla and SpaceX CEO. Tesla's new 4680 battery cell represents a paradigm shift in battery production. The new cells are far cheaper and can store far more power per unit of volume. They've been redesigned as a structural element of the vehicle, resulting in a cheaper, more rigid vehicle, translating to an expected improvement of 56% in Tesla's cost per kilowatt hour. That's a game changer for Tesla, and it will enable a completely new generation of low-cost electric vehicles. The electric vehicle industry is very sensitive to battery cost, as it represents 1/3 of their bill of material. With Tesla's 4680 battery, we could see the cost of EVs dropping significantly, or the range of EVs increasing dramatically, or a combination of the two. The $20,000 Tesla car that's proven to be elusive is now looking more like a reality. I hope you guys had fun and enjoyed the video. And if you did, you've got to destroy the like button for that YouTube algorithm. And don't forget, subscribe, click that bell.